Hello, everyone. Hi, Uth.
Hi, everybody.
How's it going?
It's a busy day. It's a busy day. Hi, everybody.
Nice.
Welcome to the DevNation Tech Talk. We are extremely lucky today to have Burr Sutter here to talk, who I expect is a very tired man, given what he was doing last week at the Red Hat Summit, which I hope he's going to actually tell us all about in a second. There's some fantastic links we're going to share to the stuff that Burr's going to be talking about. And I'm going to try very hard not to interrupt him with questions, because that would be cruel. But anyway, Kevin, do you want to introduce yourself before we actually bring Burr in?
Sure, yeah. So, well, I'm Kevin. I'm on the developer advocates team, just like Uth. And we have with us Burr, who's like the grandmaster, the godfather of the of the developer advocates team of Red Hat. And so, hello, Burr. How's it going?
It's going well. We're going to be talking here on DevNation, which is totally awesome. And by the way, do you guys know about the DevNation that's coming up on the 29th?
Yes, and I'm
okay.
actually also speaking there, so cool.
Yeah, I think I got to talk also. So it just occurred to me that I need to remember all of that because that's like 2 weeks from now or 3 weeks from now.
Yeah,
Fantastic.
coming up pretty soon. Yeah, if you're not aware of the DevNation track, it's on the 29th, and we're going to be streaming pretty much a whole day, right, Burr?
I think so.
Yeah.
My plan was to kick off with the content related to platform engineering, platform as product, a session I call the developer's developer, right? Those people who build for developers or develop for developers is kind of the idea.
Awesome. All right. And so what are you talking about today? I saw the title. It sounds really cool.
Yeah, today's topic is going to be talking more about the secure software supply chain and what we have to think about as it relates to developers and as platform engineers and all the people involved when it comes to the manufacturing of software. So if you think of the word supply chain, it's all those ingredients that basically are part of the raw materials to enter your software factory, or factory in the real world if it was a supply chain. And of course, out the other end comes the finished good, hopefully the cool application that might ship to the app store if it's a mobile app, or an application that ships as a container image through your container registry out to your container runtime execution engine. So we're going to be talking a lot about software supply chain security. And we basically just did a big keynote demo at Summit last week. We also had a nice breakout session, and I'll be repeating part of the breakout session here, but we also have some fun demos and lots of live demos like I always enjoy doing. Good to see DJ Maddie here. Always good to see you. So thank you for showing up. And I'm hoping also everybody, if you're not on the public DevNation Slack, please do join us there. That's actually how you can actually get through our wait list if you're interested in trying the new product, because we have a wait list that we can let you guys in on. But I do look for people in the public Slack as well as who just send me emails, because we're interested in the people who are interested.
Awesome. And I'm sharing that link right there. So without further ado, I think you can take it away. I think you have some slides, right?
Oh, I've got all kinds of stuff.
Nice.
Let's actually start. One thing you'll see right away is I have when I go into screen share mode here, you'll see there's a QR code. If you would just zap that with your phone or, grab a copy of it. And that takes you to a little survey. So I'd love for you guys to take the little survey. And now I think about it, being that we're more desktop mode here, when I last used this, I was mobile mode. So therefore the QR code works better. And if we're a desktop mode, then I have to remember the direct URL. I have to go dig that out. I'm not sure if I have it actually. But this is just a little survey that helps us better understand where you guys are at from a where you position yourself, if you will. Like, are you more on the development side, SRE, ops, platform engineering, DevOps, etc. And then just a little bit about your journey as it relates to the CI/CD tools that you use and software supply chain security tools that you use. And that is definitely cool to have that information. So if you wouldn't mind, hit that little survey. I'll show you QR code again a little bit later. But what I want to do right now is let's play a little game. Okay, so if you could, Kevin, share the URL for the game. I believe I provided it to you earlier. You guys have probably seen this game from us before, but what I've done is I've brought it into our new trusted application pipeline. So this is what it looks like here. So this is a bunch of pipelines that have been executed, And what we're going to do is we're going to basically let you play for a moment. Then we're going to go back and make a code change. This is the new technology I'm talking about. That's up at console.red.com. This is brand new. We just launched it last week at Summit. But you'll be able to then come in and also use this product for yourself. Okay. So it's a software supply chain optimized CI/CD based system. And we're going to see if we can make it work right now. So here's our dashboard. Let me hit refresh here to make sure we're connected. And if you could provide the direct URL there. So that is the direct endpoint. I see it there. So when you guys connect, and I can also connect my phone here, you should get a version of this application in your little mobile browser. You can see we got 4 people here connected right now, but there's 2 on this blue team, 2 on the yellow team. And it's a pretty simple little game. You can see these 2 little cars that move around the track. Now, this is all brand new, so let's see if we can break this thing real fast. It is literally running in my little sandbox environment. So I'm going to hit go here. That turns it on. You would hit the propellers. I'm going to hit on my phone also. So this basically creates little energy for the wind turbine that drives your little electric vehicle around the track. And you can see here, we're going to get it going. I missed the target there. So the yellow team has to catch up. I got to work a little harder on yellow here. Oh, yellow has jumped ahead now. Let's say we got to get the gray team's got to go a little harder. I'll work on that one a little bit more. But you can see it's just a little race game, and all these little transactions are flowing through the backend system. This is a different version if you've not seen this game before, or if you have seen this game before. It is literally all running in a single pod on that OpenShift environment that is backed up behind that pipeline. So it looks like yellow is going to tear it up and win the game here. They're definitely the fastest of this particular go-around. So there we go. Let's see who was in first place. Oh. And, of course, there we go. Come on. And is it not going to actually produce the dashboard in this case? That might be true. Maybe it won't. Well, there we go. All right. So there we go. We got, looks like I ranked overall number 2. So Ramsur beat me there. Okay. All right. So that's the nature of this little application. The reason I wanted to show you that, though, is that what we're going to do now is simply make a change to it. So as I mentioned here, there's this thing called trusted application pipeline. We're going to talk more about that as we get into it. But I want to go ahead and kick off a code change. And you can see I also have a little polling interval here that basically just shows me that something has changed on the back end. Because by default, it's kind of hard to change the GUI. But I can come in here and say, I want this little message to say bonjour. It's just an endpoint. And then put in my name and, and we'll put in Kevin and Uth. Okay. And DJ Maddie. Just make a code change there. Hit save. And like you would as a developer, you're going to say git commit, right? Git commit. So this is DevNation change and git push. So the git commit, git push, of course, pushes that back out to the GitHub repo and kicks off the pipeline. So you can see right now, if I come back over here to the trusted application pipeline, you'll see it is kicked off and it's going through this whole process here of pushing through the system. Okay, so all that's happening right now. We'll come back and just see how that finishes, and we'll see how that deploys out to the production runtime environment as we get into this presentation. So let's go here and talk about supply chain security and all the things that matter there. Okay, and feel free to throw your questions into the chat, and we'll try to get to them as we can. So software supply chain security, again, is a big topic we just launched as a Red Hat Summit last week. On Wednesday specifically, we had a keynote session that we talked for about 9 minutes. And then, of course, we had a breakout session where we talked for about 45. In this case, we're going to get the longer version of those things. Plus, you guys get the cool interactive game, which we did not do last week. So in this case, if you think about supply chain security, it matters a lot right now. Just for a moment, kind of go back in time to that December of 2021. For anybody that's in the IT industry, you might remember December 2021 was the moment when we learned about Log4j. For a lot of people, they didn't even know what Log4j was. They just knew they were infected by it at that moment in time. And this is a particularly interesting issue as it relates to the transitive dependencies that you have in your application, your software supply chain. You didn't know you had Log4j. It came in via Elasticsearch, or it came in via some other application or product or technology that you've included in your new custom code base, your application. And so how did you even know that you had this thing? That was one big question. Another big factor was Log4j, the vulnerability was specifically in the code base for about 8 years before the exploit was discovered. So that time lag really, really mattered. That means you actually have a lot of it in production, still to this day, still in production, and you don't even know you have it. and you're not even aware yet of the exploit, right? Because information travels kind of slowly across different organizations, and therefore that time lag matters a lot. Because I'll give you another example, the Struts2 vulnerability that happened just a little bit before that one, which of course was notorious for having given up a lot of Americans' data to the dark web, myself included. Over 143 million Americans lost their data through that one exploit as an example. It's because information travels slowly, okay? And so if you think about the Log4j one with that 8-year lag, that meant that it's out in production. No one's actively coding. No one is actively building and running a pipeline. It is literally just in production. And can you go find it? And do you know about it? So we're going to talk about some of those issues and how we can work to address those here and with this conversation we're having right now. But you can see we have supply chain attacks up 742%. Okay, 45% of organizations, that comes from Gartner, will experience a supply chain attack. You probably also, by the way, have heard of the SolarWinds example of another supply chain attack. And that's not where they got involved in a transitive dependency. That's where they got involved via actually sitting on the build system and attaching their backdoor to everything that came through that build system. So you can compromise the build system, you can compromise the dependencies and supply chain, all of which is part of what happens to that finally built product, that binary that goes out the door. So how do you actually basically protect yourself from all those things? This is the area of focus for me. And I can tell you why I'm personally super interested in this topic. Most of you here know me that I'm kind of very focused on the concept of developer experience, developer productivity, and how we actually make developers more awesome, and how do we actually streamline that workflow to get their applications to production ever faster. Well, we have to think about the security aspects of that. If you basically ship greater exploitable software faster, you're going to lose more data, have reputational loss, and of course have systems that are, subject to ransomware and other types of attacks when they're running in the production environment, and that can be a very bad thing. So I'm very interested in this topic because now I see this as the #1 productivity inhibitor when it comes to developer capability and developer speed and that ability to ship applications ever faster is, are we also shipping software with a great security posture? Okay, so that DevSecOps mindset is super critical, and you should be thinking of it of the world of, okay, there's dev, there's ops, and the security team. There's 3 silos in big organizations typically. Sometimes there's only 2. I have found a few customers that don't have a security dedicated team per se. It's just a negotiation between dev and ops as to what CVEs need to be fixed and what security vulnerabilities there might be within their custom code. And of course, the scanners and the tools and technologies to help protect against those different issues. So sometimes it really is just a dev and ops conversation, but we're also seeing in bigger companies that it's a dev, sec, and ops conversation. And that negotiation is super critical because right now we have a throw it over the wall, just like we did between dev and ops. We have a throw it over the wall between dev, security, and ops. It's 2 throw it over the walls. And I like to think of it as the love triangle. At some point, by the way, I'm going to get around to making these images in a little fun way. But think about DevSecOps. That's the reason I'm now liking this term a lot. It adheres to the same principles as DevOps as before. But now what we're doing is introducing the security principles first and up front in the middle of this conversation because it matters more than ever before. Okay, so let's talk about those things. So most applications at this point have open source in their supply chain. It is rare to find an application that does not have some form of open source in the supply chain. That's a critical item to understand. But most people don't actually fully appreciate how much open source is in their supply chain. I'll give you an example. A Spring Boot application for Hello World has over 50 dependencies just for Hello World. Okay. And so where did those other 49 things came from? You just thought you used Spring Boot. Well, there's a lot more than Spring Boot that gets pulled in when you basically say, I'd like to build a Spring Boot based application with 49 with a single Hello World as its only actual business logic. If you look at an average Node.js application, it is over 900 dependencies to get pulled in for our average Node.js application. And then guess what? That depends on what build tool you use. So if you like in the Java world, we tend to use Maven. And that's when I look at for that dependencies I talked about earlier. I haven't looked at Gradle and I need to go and do that. But in the case of Node, you might use Yarn or you might use NPM. Well, guess what? The dependencies shift by about 200 depending on which tool you use. So you also have these circular dependencies in the case of Node ecosystem and things like that. So all these different dependencies, are you aware of them? Are you conscious of them? Do you know what their CVEs are found in those? And are you actually establishing a more secure, footprint when it comes to all those things? So way we're focused on it here at Red Hat is this concept of the Red Hat Trusted Software Supply Chain, this new thing that we just announced. And again, you can come join our waitlist and come try some of this as of right now. And what we would like you to do is try to do the code build and deploy, right? Code build and monitor. So if you look at the far side of my left-hand chart here, we actually are talking about a bunch of things. Now, people have known Red Hat for 30 plus years of giving you things like Red Hat Enterprise Linux is a good example. So 30 plus years of securing the open source supply chain around things like Linux and the Linux kernel. That's what people think of when they hear Linux, the Linux kernel, but also parts of the user space. So the kernel space and user space. So those are two critical items in the Linux community, but there's actually two more layers above that. The two additional layers are the language runtime, and you might know us for our OpenJDK work we've done here at Red Hat. You might know also that I came from the JBoss acquisition 17 years ago to Red Hat, and guess what? Java really matters to me and a lot of our customers. So the idea of the language runtime being also built by Red Hat and also curated by Red Hat, understood at the supply chain level and verified by Red Hat is critical. So what we're doing now is moving a little further up that stack. So what's new is now we're looking at jar files. So we used to not so much look at jar files as much as in the past, but now we're thinking a lot more about jar files and NPMs and pips and other types of libraries that you might pull in through your supply chain. So all that makes up the software supply chain from our perspective. We've expanded that scope, and we recognize that at Red Hat that our customers you see us as their supply chain, right? We produce these Kubernetes things, these Linux things, these Ansible deployment tools, these Java middleware capabilities with all these jar files in that world. And of course, things like OpenJDK, that is part of your supply chain. And we need to respect that. And of course, we respect the fact you've given us a lot of trust over the years as it relates to those things. But we're going to look at code, build, and monitor in today's little demo. And actually, let's not spend any more time in slideware mode. I think that's all plenty at this point. I get bored of the slides. So let's actually just dive right in and show you some of these things. So let's show you the code mode versus the build mode versus monitor mode. And actually, there's more buckets than this, but I like to think of those three. And if I go over here to my IDE as a developer, you saw me use it earlier. Instead of that one, though, I'm going to bring up this one over here. Okay. And you can see right here in the POM XML, if I look at it, I've actually purposely injected a bunch of ugly things. So this is the beautiful Struts 2 vulnerability that took down 143 million Americans as an example, right? That let our data out to the dark web. Here's Log4j, that one that's costing us billions of dollars to go out and remediate within our overall IT industry at this point in time. So here's the idea behind this. Inside the Visual Studio Code or IntelliJ, we will have real-time analytics, real-time warnings that basically say at the point of entry, when the developer injects the bad thing into the code base, we can warn them at that moment. So yes, you just used that bad Struts 2 as an example. Okay, so that's a key element here. We are partnering with Sneak on this. This is a dependency analytics plugin. I have a different version than the one you have in the public right now at this point in time, because I have the newest one that we just demoed last week. And so I'll show you some differences between the new one versus the one you can have today. But this is something you can go down to the Visual Studio Marketplace and download and install yourself and open up your POM XMLs and start seeing some of this activity right away. Now I'm showing you POM XML here, but we'll be expanding this to requirements.txt and package.json. And I believe those actually work in the current version, but we're going to be doing more along these lines. Now, it should be noted, it's not just the warnings of CVEs. That's relatively easy, right? We can match up your dependency with a CVE database. Sneak provides that for us. And again, they're our partner here and a very critical partner from that perspective. But we're also going to be identifying dependencies that we rebuilt. So this is a key element. A lot of people aren't aware that Red Hat actually rebuilds some of these dependencies that you might otherwise drag from Maven Central. And guess what? If you go to maven.repository.redhat.com, you can find these dependencies that we've rebuilt. And we can make specific recommendations around them. So here's an example, the Quarkus Vertex HTTP. If you use the upstream one, right, the normal one you find out in Maven Central, there's a vulnerability associated with it. And guess what? We have a rebuild of it that you can actually download from us. And so if I click on that, you can see the -Red Hat there. So that's actually one of the indicators is the -Red Hat in the name. And by the way, I'd love your feedback on this because we've debated often, should we have a -Red Hat in the name of the artifact? And we did that so people would know when they've switched from a plain old Maven Central one to one that Red Hat has rebuilt. But here you go. You can see if I click on it, we also are now working to produce an SBOM, software bill of material. And if I click on that, let's see, it opened up in a window over here, but I'll move down here. Okay. You can see it's based on Cyclone DX, and an SBOM, software bill of materials, is a big old JSON file. All the ingredients in there, okay? The ingredients. So think of this as the food packaging list. If you go to the food store and you get a package of product, you'll see this nice list of ingredients on the back end of that. At least here in the US, it's important that we publish things like this product has nuts in it for people who have a nut allergy. This product has gluten in it for people who have a gluten allergy. This product has shellfish in it. Anything of that nature. This product has, animal byproduct, and I'm a vegetarian. So all that stuff goes on the back of the ingredients list. And so this is the same idea. What are the ingredients to that software? And the software bill of materials, or SBOM, is a key element of that. We also have the VEX, and the VEX is another metadata file, and I'll just show you that quickly, that is a little bit different, because the job here is to basically say, and VEX, by the way, stands for Vulnerability, Exploitability, Exchange. And this file is particularly interesting because, okay, you have the ingredients, but are you allergic to it, right? The package says it has nuts. Yeah, okay, so that's what it says on the package. That's the SBOM. Now, do you have an allergy for nuts? Okay, so you need to know that too. And so this is where the vendor would provide, like us in this case, hey, we know there's a big exploit on that thing, right? There's an issue, and here's the remediation associated with it. So that's what this document is for, right? To basically provide the recommendation as to what you should do about the thing that you might be allergic to, as an example. So that's a key element. That's why you see those two linked here. This is the new element, by the way, that's not available on the current plugin if you download it today, but because it was just built for what we have and we'll be iterating going forward. But again, I would love your feedback on more of these kinds of things and what area that you have, areas of interest that you have here. You can always just hit me up on Slack, and let me check Slack real quick to see if anyone joined us there. Could be. No, well, I see. I did get a little notification. Someone must have joined over there. But, feel free to throw questions at me from a Slack standpoint, even after today, or if you're just watching this recording. All right, so that's Red Hat Trusted Content. That's what we're doing at the code mode. There are a couple other things to be thinking about in this category. We also have a project called SigStore, where you can do artifact signing, including a keyless signing technique using a transparency log. That's a big popular topic. We'll see more about SigStore in a little bit. So that's another thing you might use on your laptop in code mode. And there's another tool that we have that is very interesting, and it's part of the build side, so it'll help us transition to the build conversation. If you do not see a rebuild here, okay, and you can see there will be plenty of things that Red Hat does not rebuild, or we not really made a surface the recommendation at this point, we have a new pipeline, all right, the Red Hat Trusted Application Pipeline, which gives you the rebuild technique, all right? So what you're about to see here when it comes to this Trusted Application Pipeline, let's just flip over to that mode here, right? So this is the pipeline that's been running, and it looks like it's been finished over here at this point in time. And actually, let me see if I can check my curl command. Yeah. So did it get updated here? Oh, I must have made a change. There it is. There we go. So that was the change that I made there, right? You can see the bonjour, right? So that pipeline is finished, executed, and the application rolled out from a CI/CD perspective. We'll talk more about that in detail here, but you can see the change is pushed out now. But in this case, this pipeline ran end to end, but this is an example of the Red Hat opinionated productization pipeline. This thing you're about to look at right now was built for Red Hat productization engineers, and what we've done as a Red Hat Summit is made it public to everyone here in this call right now, or at Red Hat Summit last week. So this is new, but because it's part of that productization world that we live in, one of the productization tools we have is known as a rebuild feature. So in other words, take that Java dependency that Red Hat has not pre-rebuilt, and you can rebuild it. And it will spider through all its transit dependencies, tell you if there's source code associated with all of it, because sometimes there's no sources, tell you where the shaded jars are, and basically help you rebuild that world. If you're interested in that topic, I'd love to talk to you more about it, because that's a very special feature that some people are very interested in, as an example. And it is available by way in this environment you see here. So let's actually go now into what it takes to get started. So let's say you got approved off the wait list. You would come in here now and have, you would see these button here, create application. You won't see view applications unless you have applications. I already have a couple out here. You can see I have these two. I have the Ship Wars game servers being worked on, of course, that wind turbine application. But I'm going to basically grab a simple little application from my Git repo. So as a developer, you're going to do a Git commit. You're going to do a Git push. Okay. And then you're going to basically say, now grab it and bring it in over here. So I'm going to paste in the Git repo there. It has to be a public Git repo on GitHub. I'm going to hit import code. I could basically specify a branch or or maybe a context directory if there's some subdirectories in that, but it's a plain little Spring Boot application in this case. So you can see
is there anything that we need to add to that repository? Or is it just a plain old Java application, just your pom.xml and all that stuff, but nothing specific to this pipeline, right? Okay.
Yeah, there's nothing in here right now. Nothing in here right now. So well, we are considering making a change to that. Like we might require you to bring a Docker file, but right now we give you a Docker file if you don't have one. All right, and we give you what's known as a dev file if you do not have one. So here you can see I have nothing. It's just literally a vanilla Spring Boot application in this case. It's true of Quarkus, same is true of Node.js, Python, etc. And you can see here, when we make a recommendation, we pick one. This is actually something that I know some people have run into as a problem. Do not change the recommendation. We made the recommendation. It's fixed. If you change it, it will break. That's an area though where the maturity of this project has to get better. And I'd love to know what you're trying to import and where we may have failed and where we may have given you the wrong recommendation. So you can see here, we're looking for Node files, Quarkus files, Spring Boot files, Python files, Go files, and a Docker file. And if you have your own Docker file, that overrides all other behavior, right? You basically are now in control of what it means to do a Docker build, if you will, on that particular project. If you have a dev file, it'll populate these items here, but we don't expect a lot of developers to bring a dev file. And again, we're looking at overhauling some of this logic as it is. But the whole goal of this was that within a couple of clicks, you can create that application. So I didn't do anything more than paste that in, and I hit create application. And now it's fully wrapped, enveloped, if you will, with a CI system and CD system, all the GitOps repos, everything generated for you automatically. And you can see my build here is now kicked off. So here's that pipeline run again, and I'll just show you what that looks like. And I'm having some errors today with console.reddit.com. Let's see. Let's try to get in here. And here, will it go through? Come on, refresh. Sometimes you just got to refresh the browser. I got to go track down where that bug is. It just showed up today. But you can see here, there's the pipeline that we showed you earlier, but it's now going through the process, right? We don't have to wait for this one to finish. But the idea now is it's going to do a git clone. It can optionally prefetch dependencies. This is if you're doing a network isolated build. So that could be an important element for the user. It's then going to do a build container, and it's going to build the artifact, Maven, Maven package in this case for a jar file. It's going to build the container using Builda. It's going to analyze the dependencies. It's also going to produce the SBOM, right? So the software bill of materials is manufactured through this task. And in the case of the default pipeline, out of the box, the simplest one you get for free, it will skip all these tasks here in the middle. So you will see it jump from build container all the way over to show summary and show SBOM. And let's show you what that looks like when it's done. We won't wait for that to finish. It'll look something more like this. You can see the green check marks here and here. And there is the SBOM available here. Let's go see if I can open it up. And again, it's going to want to complain to me about the HackDev plugin. This might be, by the way, why I'm seeing this is related to the fact that if you notice what I'm doing here, I have Firefox sequestered into multiple users. And that's actually sending a lot of load to console.reddit.com from a single browser. And that kind of messes things up a little bit. We actually have some DDoS protection that sometimes also gets in the way here. But there's my SBOM as an example. And if I go back to that main screen, you can kind of see what the pipeline looks like. And one thing I want to show you here, though, this is the default pipeline that you get out of the box for free. There's an upgraded pipeline that runs all of the tasks and is customizable by you. So let's say you don't like our default pipeline here. You can modify it to your needs. So the way you go about that is you come in here to components, and we'll go to components, and you can say manage the build pipeline. And don't worry about that part updated. That's a bug we have in the system today that we got to go fix. But you can say manage the build pipeline. And now what's going to happen is it's going to basically send a pull request out to your GitHub repo. Again, make sure you use public GitHub repos. We're focused on that right now. Everything here is open source. So everything is done in the public, if you will. So we're using public GitHub repos. So I'm going to send that pull request. And obviously I need to be able to receive it. It needs to be a repo I own. But let me hit send pull request here. And it looks like I got an error. Let's see here. It might be I need to install the GitHub application. Yeah, it looks like I got to install it. And we're going to go through that process here, install, and this is the Burr Zynga account, so it's good. And I need to log in apparently, haven't logged in a while, and now it's installed. And let's go back here now and see if we can send that pull request through. Let's see if it'll go through this time. So the GitHub application is a prerequisite to get that pull request to work. And that is because that is the webhook generator. It's the way we interact. And we actually won't send you, we will send you the initial pull request, but we'll also send you upgrade pull request for your pipeline over time. So let's go merge it. So here's the pull request or merge request you see here. I'm going to just go ahead and confirm it and merge it. And you'll see what happens is the Delta is inside that repo now. And so this is the Burr version. There's now .tecton folder. So Kevin, you asked, are there any special files? Now there are some special files, right? Because we now have basically submitted the whole pipeline to you, practicing pipelines as code. And the developer now that can basically modify their needs. All right. So it is a Tecton-based pipeline based on Tecton chains. You can see that it will be running here in the background. Once you basically receive that merge request, if I come over here and I can see there's a pipeline running. Okay. So we won't wait for that to finish. Let's show you what one that's finished and customized looks like. So here's one that's finished and customized. You can see all the little things are executed except for the sneak one. For the sneak one, you got to bring your own sneak token as an example. And we don't go ahead and prefetch dependencies network isolated by default. You got to turn that flag on. So those two were not executed, and that's why they're there in gray. But there are some new ones that I added in this case, and that is one for rockctl. This works with the ACS, the monitor side of it. So when I say ACS, I mean this guy over here. We'll come talk about that in a second. But with the ACS, I now can do CV scanning. That's important. But more importantly, it also do recommendations based on policy. So if I have a deployment YAML, a secret YAML, things like that, it'll basically look at those YAML files and basically say, are they do they adhere to policy? So that's a nice capability there. There's also a trusted content one, and the trusted content one would give you those dependency recommendations. So depending on the tool you choose, right, you would get different recommendations for different reasons, and you can include whatever you'd like in your pipeline. So you can customize your pipeline. In this case, I did those two in a special way, but you can add whatever you would like there. If you can run it on a Linux container image, and let's say it's a CLI-based things, both those are CLI-based things, right, command line interface, then it will just be something you package up and put in your Tecton pipeline. Now, I did mention that when the pipeline executes, you could customize it, and you see me customize it here. That does present a risk, though, to your security and compliance team. So yes, we're getting an SBOM now, we're doing CVE checks, antivirus checks, we're doing all those things, but I still need to really verify that it meets what's known as SALSA, supply chain levels for software artifacts requirements. Okay, so a lot of people have not heard of SALSA, but supply chain levels for software artifacts is a set of guidelines that comes from a group of industry players like ourselves and Google. And this is where we tell you some of the things you ought to do. For instance, you should build in a kind of a sealed, protected, hardened environment. Don't build on the developer's laptop, because if you're building on the developer's laptop, they can throw their little crypto miner in there. And I can almost guarantee you, if you run in a big organization, you got some crypto miners running in your infrastructure at this point in time. We spend a lot of time here at Red Hat chasing crypto miners off our infrastructure. So it's the nature of the beast, right? If you can get some free crypto out of it, well, you know, a web application doesn't use a lot of CPU. So why not let the crypto miner run in the background and generate a little extra Dogecoin or whatever the heck it's doing over there? I'm not a crypto person, but I'll show you an example of that later. But you want to build in a hardened environment, so therefore people aren't dropping in stuff they shouldn't be dropping in. Okay, that's the nature of supply chain security. So what happens is when you see that build occur, let's go back over here. Okay, we are basically, as this build is occurring, we're putting in a bunch of things into that process. And let me just show it to you, make it really obvious here. I'm going to use the cosign command. This is SigStore cosign. Let me come over here and here. Okay, so this is going to pull the SBOM down. So the SBOM is one of the artifacts generated through the pipeline. But let me show you, and you can do cool things like grep for it and look for struts. You might be allergic to struts, like I said earlier, like you might be allergic to nuts, or you might be worried about that log4j. So again, you can search your ingredients just using a grep command, and it's a container image that's stored out there, in our case in Quay.io. But let me give you another example of this, and let's go in here and say cosign tree. So this is where you get to see all the good things that happened. Because building container image is very easy, right? Docker build, podman build, builds your container image. We did a lot more than that. We built the container image, but we also signed the elements of it. We put attestations for everything, and we have the SBOM. So you get the signatures, the attestations, the SBOM, all of that wrapped with the container image. And by the way, all of this can be shipped to wherever you need it to go. You can use Scopio and move it to whatever your favorite container registry is. Okay, so in this case, we do put it in Quay.io by default. And so you could also go run these same commands and go look at my images and look at those things here as an example. But that all happens within the context of this pipeline. So that's what's happening here. Those attestations have to be in place. And that is what this tool known as Enterprise Contract is looking at. It's basically going, did you do all the steps you're supposed to do? And I'll give you a simple example. Yes, you can customize your pipeline, but you cannot remove CVE scanning. So let's say you have a developer out there who's a little bit, clever. They're like, they don't want to fix the CVEs in their code base. As developers, we don't really want to go chase those things down and fix them. It's a pain in the butt. So maybe I just remove the CVE scanner. Think I'm super clever. You won't even know I have a CVE because I removed the scanner. Well, we will still check that you did CVE scanning, right? We'll look for things like that. So that's the nice about this tool is it basically looks to see that all things were executed. You basically pulled images from a permitted base, permitted registry. There's no blocking CVEs, and all that's part of known as SLSA, SLSA. You can go to slsa.dev, and that's supply chain levels for software artifacts. I'm showing you 20 rules here. There actually have 43 out-of-the-box rules. We can see more here, like there's different policies. You can go look at the documentation for it. But that is all part of how we validate that you did all the right things in that build, as an example. Once the build has occurred, then it just rolls out. And let me see, I think I have this one set up for environments. This uses Argo CD, a GitOps repo is generated and rolls out. Now, I shut down 3 of these clusters because I didn't, my credit card was on fire. But I was running 7 different clusters, or maybe 8 last week. Now I just have 1. So this will roll out to, of course, your OpenShift, your Rosa, your Arrow, but GKE, EKS, and AKS. I still have my GKE running in Frankfurt, and it's getting deployed out there, right? So any change I make goes through the CI/CD pipeline, validates it through Enterprise Contract. If everything's green and good, ships out that container image out to that new cluster using GitOps, using Argo CD. This uses Argo CD push, not Argo CD pull. It does produce the GitOps repo, but we use a push technique in this case. So you can register for that environment here. Come in here and say create environment, give it a name. Deployment strategy is only automatic. We're going to add a manual relatively soon, but you can decide if it's an OpenShift cluster, you want to bring your own cluster, OpenShift or non-OpenShift, and then of course give us your kube config for a non-OpenShift one as an example. Okay, and provide the ingress domain also. So that's kind of how you would set up an environment. And if you have OpenShift clusters, it's a little bit easier because you don't have to worry about the ingress side of it because OpenShift clusters have ingress built in. So if you're interested in that, OpenShift is the easiest one to use because you don't have to figure out how to ingress for GKE, EKS, AKS. I did that for that other one that you saw earlier, right? Which actually takes a fair bit of effort. If you're interested in GKE and ingress, I can have some notes I can ship you that are out there on my GitHub repo. Okay, so that is the deployment side of it. And that is the build and deploy. So if you're over here, right, we did artifact building, image scanning, deployment gates. Now that has rolled out. This is known as Red Hat Trusted Application Pipeline. And like I said, it's on a wait list, but if you join us on Slack, you can come find me and we'll talk to you and let you in there. And we'd like to bring you in because we're having people kind of in that beta test mode with us right now. Let me show you now about the monitor side of it, the runtime side of it, because this is also very important. Remember that issue I talked about with Log4j as an example? If you have it in the code base for 8 years, you probably no longer are actively maintaining the code that has a transparency. Therefore, you're not actively coding. Therefore, you won't see it in the IDE. And if you're not actively Git pushing, you won't see it in the build pipeline. It is just literally in the production runtime environment. And that's the only way you would become aware of it. And so here's the dashboard here. The things we really like about this advanced cluster for security. And by the way, this is now cloud service also. You can come point and click your way at console.red.com and get one of these. I'm literally running it for myself right now. So come console.com and click one. This is my version of it here, and you can get the same thing. Now, what I have done though, is I did have a bunch of clusters that you have loaded in. As I mentioned, I had about 7-8 clusters last week. I only have my Frankfurt one left. So you can see that some of this data is going to come from those clusters I tore down. The good news is it caches all the data for me, so I can show you all this information, even though those clusters really are gone, right? Except for one of them. You can clear out that cache, but that's how I have it set right now. And you can see there's going to give you this high-level dashboard. It's going to also give you things like compliance around certain things like CIS benchmark, CIS Docker, CIS Kubernetes, HIPAA, NIST, things of that nature, right? Well, that's really nice. PCI DSS, right? You can understand those compliances and those policies, and there's a bunch of compliance controls out of the box. But you can also drill down on a specific namespace. Like in this case, I might want to work with the back end people here in Frankfurt and say, hey, your applications, because typically you have applications in a certain namespace, right? The HR applications, the finance applications, the manufacturing applications, they have typically put in a namespace. But I would basically say, hey, you guys are only 49% compliant with our controls. Let's talk about how did we get you fully in compliant? And I can basically drill down on things from that perspective. I also like how this also will sort these issues by risk. And you can see here's backend Atlas. Okay. And it'll tell you what the policy violations are, compliance and policy violations we talked about. You can see we have Apache struts, we have crypto mining. But one thing that's kind of cool is you can take use process discovery. So it's not just image scanning. So it does image scanning, but it goes beyond that. It also does process scanning. And so you might have something in your image, but one rule of thumb is it takes 2 CVEs to become a real exploit. Typically 1 CVE is not exploitable on its own. It requires like 2 major failings in terms of your security posture for someone to get in. But what you can do is take a baseline here. Okay. Where's that button here? Right. That's this little command down here. That's just a little lock. And then what's going to happen, it's going to monitor that process and look for people doing bad things. Now, in this case, the crypto miner who got into my pod here was in fact me. You can see, I can tell because I'm getting the crypto back to my email address. But basically I was able to get into that pod, run things like tar, maker directory, gzip, cat, whatever I wanted. And of course, run a crypto miner. And the things you look for are things like, okay, who's running apt get install, yum install, things like that. Because you don't necessarily want people running wget. You don't want people running package managers. That is where they can go in there and really just own your environment if they want to, run all their crypto miners if they want, steal your, et cetera, et cetera. So that's a very powerful tool to basically look at it from a process standpoint, a very favorite feature of mine. And there's a lot of good stuff here. Let's look at the network tab. Another thing about being in the Kubernetes native security world, let me pick a cluster. My Frankfurt one is still good on my namespaces. So like, here's a real fun example. Okay. So I loaded up this cluster with all kinds of stuff, right? There's all kinds of goodies in here. And here's one thing a lot of people don't understand about Kubernetes. When it comes to these namespaces in particular, the network in Kubernetes is flat by default, meaning everybody and every namespace can see everybody else by default. That's just works. And the good news is for developers, that's awesome. It makes our development cycles a lot faster because we're not figuring out why the hell A cannot connect to B. It can be bad for what's thought of as lateral movement. So let's say you have that old crufty WordPress sitting in your marketing namespace, because we don't update that WordPress that often. It's just a marketing website that we don't even pay attention to. Well, let's say that there's a nice CVE and vulnerability in that WordPress that people can use as a backdoor, and now they have a remote exploit. They're actually accessing your system, and they're in that pod now. Well, guess what? By default, they can see your finance namespace, your manufacturing namespace, your human resource namespace, right? Every other namespace in that cluster by default. So one of the things we have here is the ability to simulate network policy and generate network policy to help you lock things like that down, right? As an example. So that's one of my favorite things to think about is like, okay, well, maybe I really want to sequester these things across the different namespaces. So the marketing one, won't be a problem and they won't have access to our finance information or our human resources records, et cetera, as a simple example. So lots of capabilities here at the monitor side of it. So that is our code, build, and monitor. And there's also storage that's happening. As I mentioned, everything gets stored in Quay. And you kind of saw that earlier when I pulled out the SBOM and pulled out the tree via cosign. So everything goes into Quay.io. I don't have that URL working right here and now, but that's where everything is stored. So that's the fourth element. And that is how we think of securing your software supply chain, is bringing all these components together and showing you how we can help you save some time, right? And of course, hopefully save some money, and more important, perhaps save some headache. Now, I know we're kind of over time here, so let me pause for a second and see if Kevin, Uth, you guys have a couple of questions or some thoughts for me.
Yeah.
I mean,
sorry, Kevin. I've got a question. Basically, I love this. I love this to pieces because every single customer I've been talking to the last 6 months has been trying to build it themselves. But a quick question on the build side. What do we do under the covers to introduce and maintain multi-tenancy? Because it's quite a hard pitch to talk to customers and say, yeah, this is a managed solution. So you can be building your software in the same place that your competitors building your software.
Yep.
And I know under the covers that we've got a couple of really nice features that produce some multi-tenancy on the build side. And this is the one question I get asked all the time when now I'm allowed to talk about this since Summit. So can you give a little bit of kind of oversight into what the multi-tenancy concepts are that are used as part of the build process?
Yep, very fair, very fair. And I'll give you a couple of examples. So by default, if you guys are familiar with our sandbox, right, the developer sandbox that you see out there at developers.red.com, that uses a very special capability that we built on top of OpenShift and Kubernetes known as namespace as a service. And inside the context of that namespace as a service, we specifically harden each of those namespaces so they cannot see each other. The quota, the RBAC, everything is locked down so that the Uth namespace is different than the Kevin namespace, which is different than the Burr namespace, and they truly are invisible to each other. And they also have their own quota, cores, right, et cetera, so that they can't overuse resources on the cluster. They can't overtax it. And like I said, from an RBAC perspective, you really have no visibility to other namespaces within the cluster. So that is how we handle the multi-tenancy underneath the covers by default in this model that you see here with the trusted application pipeline. And there's another factor that's part of the build also, the build itself, and that is we can spawn ephemeral environments, because if you really want to get further locked down on that build process and the testing process in particular, we also have an ephemeral environment idea where it's just a dynamic namespace as a service that is basically built up, things execute within it, and it's torn down. And that helps you with things like related to that SolarWinds attack, where, the people actually lived on the build server, right? They just lived in the build virtual machines and just simply said, oh, everything that comes through here, let me attach myself to it. And if you have that ephemeral concept, then you can't attach yourself to it, right? It comes and goes. You have to basically be part of the source code that got in at that point. Very fair question, though.
Yeah, I said that didn't originate with me. That's every single customer's asked me that.
Yep.
And there's another very, very, very quick one if we got time, and that is that when you're using the concept you talked about, the customized Tectons pipelines as code, I've had a good dig into that. It's fantastic. I love the idea of it. We use bundles to expose the tasks that can be used as part of the pipelines as code. Is there intention within the future for Red Hat to produce usable bundles of common tasks that people are using in these kind of customized pipelines, as opposed to the one that we produced and actually ship as the basic pipeline? Is that on the roadmap?
Well, when you say customized, not customization the way I showed you here. And by the way, Christian's letting me know that the share was not shared, so we're going to share the share, right? So get it really shared here. So here we go. And Christian, thank you for that. And I'll add that link to the Slack, because he's over in Slack. He found us on Slack, but I'll add that link up here in the chat also. But the shared one now. I forget that by default, a Red Hat document doesn't truly share unless you work a little harder on it. Okay, no, and so the question related to the customization, yeah, you at this point the customization happens via that Tecton folder within your Git repo.
Yeah.
Yeah, and so that is the customizability we have today. Though I know customers are interested in further customizations capability going forward. Do you have a specific use case?
Yeah, it's basically the tasks that we actually insert into those pipelines. We pull from this new concept called bundles. So rather than using the cluster tasks that we used to use, we have these bundles of pre-approved tasks that we can use as part of the Tecton pipelines as code.
Right.
And it's a new feature, but I'd love the idea going forward that we actually produce a set of these archetypal tasks in bundles that can be used as part of the customized pipeline. Because it seems to be, it gets a little bit more complicated when people have to put task specs directly into the pipeline as code. But it's the way that we're going. It's just, I was interested whether or not it's on the pipeline, on the roadmap going forward.
We'd have to dig into that use case. We've not had any feedback in this area so far. You're the first to kind of bring up that area of concern. And so we should dig into that. Yeah, by default, these are what's called bundles. They're container images, right? So Yeah, we assume you're going to use a container image to basically bundle up the task, and that's what we basically pull into the pipeline. In my case, though, for these two examples of customizations, I just made up my own thing, right? So you can also not use bundles as long as you just use a container image.
Yeah. I say it's absolutely not a concern. It's just the customers I deal with, they love to have an archetypal set of suggested tasks that they can actually put together like Lego bricks. And this seems like an ideal opportunity to do it.
Yeah, definitely. There's a lot of interest in that category of even working on perhaps a marketplace-like idea. So there's third parties that can have their task, and that exists in the Tecton world, but we'd have to do a little bit more work here to basically say, okay, these are the ones certified for trusted application pipelines, an example.
Absolutely, absolutely.
Kevin, you had some questions also?
I didn't have a question. It was just more a remark, like from my side as, like, let's say a developer, having to deal with all that security stuff is super hard. And so this is really cool because this makes it a lot more simple for me. And, like there's a lot of different ways that you're scanning there and looking for vulnerabilities and making sure, my code is good without me being an expert. So I really like that.
Yeah, we hope at this point we are engaging developers and different platform engineering teams, DevOps teams to basically, spend time with those customers and talk to them. And that's actually part of the reason why we have the wait list. I want to talk to everybody as much as possible. Christian, as an example, spent some time with me already. The guy who was asking on Slack about the viewability of the document, right? And I had not set correctly on Google Docs side. So you saw me fix that real fast. But so he and I already spent some time together. He works a lot within the Linux community as an example. He's one of our Red Hat Enterprise Linux gurus. And so it's good to show him this technology and have him look at it. And we've been doing that with a lot of different customers at this point in time. So I would love for anybody here or anyone seeing this recording to reach out to us, find us on the Slack, find me via email, find me via Twitter. You can find me a lot of different ways on the internet. And of course, you can go to that Red Hat red.ht trusted link, which is the marketing page. And you can also click in from there also to find the console.red.com and the wait list from that perspective.
Excellent. That was really, really cool. I'm not sure. I don't think we've got any more questions, unless Kevin's got another one.
No, and I don't see any questions in the chat. So if anybody has any questions, now would be the time to post them. If not, you can find Burr in that Slack channel. I'm going to share it one more time, just in case somebody missed it. There we go. And you can find us there. You can ask your questions. If there's any feedback, we'd love to hear it. And if not...
And that is our standard DevNation public Slack. We'll be using it again when we do our DevNation Day on the 29th, 3 weeks from now. And of course, we use it for these kinds of events. So we're using it for this product launch also. Just feel free to come join us out there and talk to us. You'll see there's some people who have done so. And then, we would love your feedback.
Cool. Oh, we do have a question from DJ Maddie who asks, does this also work for Ansible projects?
It does not. That question has come up once before. It's like, hey, if you think about it from an Ansible perspective, we should also secure that software supply chain and deal with the Ansible modules, things that might be coming from Ansible Galaxy, et cetera, et cetera. How do we actually do things, checking validations, CV scanning, et cetera. And so I am talking to the Ansible team about that idea, but it's not something we've had a chance to invest in when it comes to this trusted application pipeline idea here. This is very much focused on things like Node and Quarkus and Python, things of that nature. Yeah, exactly. The Ansible execution engines. I see that, DJ Maddie. How do we basically produce the Ansible execution engines with, of course, having secured the software supply chain and everything that goes into it? It is an interesting use case and something I need to spend more time with the Ansible team on. What you saw them do last week was EDA, right? Event-driven Ansible, and the Lightspeed, right? So that's where the AI helps you code your playbook idea, right? And so that's what we've been focused on. But great question. Something we should pursue further. Feel free to read. You know how to find me, DJ Maddie. Feel free to pound me on that one because that is something I need to remember and follow up on my own.
All right. I don't see any further. Well, I see two more comments from DJ Maddie. I don't know if you saw those.
That's right.
Yep. Okay, you saw them. Okay. All right. I wasn't paying attention enough because I was like trying to add the links to the chat and everything. All right, cool. Yeah, if there's no more questions, Booth, you want to close it up?
Yeah, sure. I'd like to say a big thank you, big thank you to Burr for actually talking to us. I know it's been an incredibly difficult time actually getting this thing ready for Summit, and I expected you to be unconscious at this point. So
right.
Nice to see you awake. But again, it's always nice to have Burr come and talk to us. I think you should come and talk to us again about this kind of stuff.
Well, 3 weeks from now, we'll be talking about platform engineering and how to be the developer's developer.
Yeah. But I say, one on that note,
join us on the DevNation Day in 3 weeks, 29th of June.
Yeah, that's a day stick in your diary. Okay, I'll say on that note, I think we'll call it a day. Thanks everyone for attending. And again, remember there's a public Slack channel if you want to keep throwing questions at us. But other than that, thank you for attending.
Right. Thank you so much.